Section 312.5c of the National Electrical Code, or NEC, prohibits running cables through holes in wall panels. This is primarily due to the risk of damage to the cable insulation from the sharp edges of the hole, which can lead to electrical shock or fire hazards. Regarding bundling, you may need to derate cables if they are bundled together. Bundling increases the heat generated by the cables, which can lead to overheating and insulation damage. NEC Table 310.15b2 provides guidance on derating for bundled cables. To determine if derating is needed and to calculate the appropriate derated ampacity, follow these steps. Firstly, determine the number of cables in the bundle. This is a critical first step as the derating factor depends on how many current-carrying conductors are bundled together. Secondly, identify the type of cable being used. For example, THHN or NMB. Different cable types have different insulation temperature ratings, which affects their ampacity and derating requirements. Thirdly, refer to Table 310.15b2 in the NEC to find the correction factor for the specific number of cables in a bundle. This table provides the derating factors that must be applied. Fourthly, multiply the cable ampacity by the correction factor to obtain the derated ampacity. This derated ampacity is the maximum current the cable can safely carry in a bundled configuration. Here is an example. Assume you have 5 THHN cables bundled together, and the ampacity of each THHN cable is 25 amps. According to Table 310.15b2, the correction factor for 5 cables is 0.8. Therefore, the derated ampacity of each cable is 25 amps multiplied by 0.8, which equals 20 amps. In this scenario, each cable can only safely carry 20 amps due to the bundling. The conduit you installed for future access is a good practice and is not affected by 312.5c. The 2-foot section where the cables are bundled should be derated if it is not separated from the rest of the cable installation. Consider that the length of the bundling impacts the need to derate. The NEC specifies that if conductors are bundled for more than 24 inches, derating is required. If the bundle portion is shorter, derating may not be necessary. When determining ampacity, start by identifying the conductor size. The ampacity of a conductor is determined by its size and insulation type. This information can be found in NEC Table 310.16. Ensure the conductors you are using are suitable for the intended application. Consider the temperature rating of terminations. Terminations such as breakers and equipment terminals often have temperature limitations. The lowest temperature rating of any connected termination dictates the maximum allowable ampacity of the conductor. This is particularly important when using higher temperature rated conductors like THHN. Ambient temperature also plays a role. The ampacity of conductors is based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature exceeds this, additional derating may be required, as specified in NEC Table 310.15 bone. When running cables through bored holes, ensure the holes are properly sized and do not damage the cable insulation. Using grommets or other protective measures can help prevent insulation damage. For bundled cables, using cable ties or straps to keep them neatly organized can help manage heat buildup. However, avoid over-tightening the ties, as this can also contribute to heat retention. Remember that voltage drop is another factor to consider when sizing conductors. Ensure that the conductor size is adequate to prevent excessive voltage drop, especially over long distances. The NEC provides guidelines for voltage drop in informative Annex C. If cables are installed in conduit, the fill percentage of the conduit must comply with NEC Chapter 9, Table 1. This table specifies the maximum allowable percentage of conduit space that can be occupied by conductors. Always use appropriately rated overcurrent protection devices, such as circuit breakers or fuses, to protect conductors from overload. The overcurrent protection device should be sized no larger than the ampacity of the conductor it protects after any applicable derating factors have been applied. When making electrical connections, use properly rated connectors and ensure they are securely tightened. Loose connections can cause excessive heat buildup and pose a fire hazard. Always follow the manufacturer's instructions for installing and terminating cables and connectors. If you are unsure about any aspect of electrical wiring or derating, it is always best to consult with a licensed electrician. Electrical work can be dangerous, and it is important to ensure that all work is performed safely and in accordance with the NEC and local electrical codes. Correctly derating conductors is essential for preventing overheating, insulation damage, and potential fire hazards. It is an important part of ensuring a safe and reliable electrical installation. When determining the number of current-carrying conductors, consider neutral conductors. In a 3-wire circuit consisting of 2-phase conductors and a neutral conductor from a single-phase system, the neutral conductor only carries the unbalanced current and is not considered a current-carrying conductor for derating purposes. However, if the majority of the load consists of nonlinear loads such as electronic equipment, the neutral conductor may carry significant harmonic currents and should be considered a current-carrying conductor for derating purposes. In a 3-phase system with a neutral conductor, the neutral conductor is only considered a current-carrying conductor if the majority of the load consists of nonlinear loads. Grounding conductors are never considered current-carrying conductors for derating purposes. When using Table 310.15b2, note that the correction factors are cumulative. For example, if you have more than 20 current-carrying conductors bundled together, the correction factor may be quite significant. The NEC permits the use of adjustment factors instead of correction factors in some cases. Adjustment factors are used to account for factors such as conduit fill and ambient temperature, while correction factors are used to account for bundling. The NEC also provides specific requirements for derating conductors in underground installations. These requirements are found in NEC Table 310.15b3. When installing cables in thermal insulations such as in walls or ceilings, be sure to follow the NEC requirements for spacing and ventilation. Cables that are completely surrounded by thermal insulation may require additional derating. If you are using multiple cables in a parallel configuration, the NEC requires that the cables be the same length, conductor material, and insulation type. This helps ensure that the current is evenly distributed among the cables. Always keep a record of all electrical work performed, including conductor sizes, ampacities, and derating calculations. This information can be helpful for future maintenance and troubleshooting. Remember that the NEC is updated regularly, so it is important to stay current with the latest requirements. The NEC is not a substitute for proper training and experience. It is essential to have a thorough understanding of electrical theory and safe work practices before attempting any electrical work. A thorough understanding of Article 310 of the NEC is crucial for properly sizing and derating conductors. Article 310 covers the general requirements for conductors, including ampacity, insulation, and installation methods. It's also worth noting that local jurisdictions may have additional electrical codes or requirements that must be followed. Always check with your local building department or electrical inspector to ensure compliance with all applicable codes and regulations. When working with existing electrical systems, be sure to identify and label all conductors properly. This can help prevent confusion and ensure that future work is performed safely. When adding new circuits to an existing electrical panel, be sure to perform a load calculation to ensure that the panel has sufficient capacity. Overloading an electrical panel can lead to overheating, breaker tripping, and potentially dangerous situations. Using a calibrated amp clamp meter can help you measure the current flowing through conductors and verify that they are not being overloaded. Before working on any electrical circuit, always de-energize the circuit and verify that it is de-energized using a properly rated voltage tester. Never assume that the circuit is de-energized, even if the breaker is turned off. Always follow lockout/tagout procedures to prevent accidental re-energization of the circuit while you are working on it. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools when working on electrical circuits. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. Consider using a cable management system to keep cables neatly organized and prevent them from becoming tangled or damaged. A well-organized cable installation can make it easier to troubleshoot and maintain the electrical system in the future. When installing cables in a commercial or industrial setting, be sure to comply with all applicable safety standards and regulations. These standards may include requirements for fire resistance, cable support, and grounding. Regularly inspect electrical systems for signs of damage or wear. This can help identify potential problems before they become serious hazards. Replace any damaged or worn components promptly. Consider using a surge protective device, or SPD, to protect sensitive electronic equipment from voltage surges. Surges can damage or destroy electronic equipment, so it is important to provide adequate protection. When installing cables outdoors, be sure to use cables that are specifically rated for outdoor use. These cables are designed to withstand exposure to sunlight, moisture, and other environmental factors. When burying cables underground, be sure to follow the NEC requirements for burial depth and protection. Cables that are buried too shallow may be damaged by digging or other activities. Consider using a ground fault circuit interrupter, or GFCI, to protect circuits that serve wet locations such as bathrooms and kitchens. GFCIs can help prevent electrical shocks by detecting ground faults and interrupting the circuit. When working with high voltage circuits, be sure to follow all applicable safety procedures and use properly rated equipment. High voltage circuits can be extremely dangerous, and it is important to take all necessary precautions to protect yourself from injury. Remember that electrical codes and standards are constantly evolving, so it is important to stay informed about the latest changes. This can help ensure that your electrical work is always safe and compliant. Ultimately, electrical safety is everyone's responsibility. By following safe work practices and complying with all applicable codes and regulations, you can help prevent electrical accidents and injuries.